Good morning. My name is Dave Watkins, and I'm an elder statesman for Omnex. And so by elder, I mean the only person who's been part of Omnex longer than me is my boss. So, and I would like to greet you on behalf of all of Omnex for joining us for this conference on electric and autonomous product development using digitalization and integration of standards conference. Short titles are always helpful. The first presentation is going to be on challenges and strategies in new product development and electric and autonomous vehicles. It's going to be presented by 𝐂𝐨𝐧𝐯, the gentleman I just referred to a moment ago. The issue is that the advent of electric and autonomous vehicles is changing the model for the traditional model for relationships with suppliers, and in particular, what we've called to characterize as the design chain. And the fact that you have at various levels along the way in the value stream, different organizations that are responsible for elements of the designs in these mechatronic systems, ultimately up to the high-level vehicle systems. And Omnex is launching a strategy for the industry that is developing electric and autonomous vehicles to integrate, digitalize, including AI, and coordinate with the design supply chain. Digital cloud-based software with machine learning and AI are a key ingredient in the recipe for success. I got my first laptop when I've been in business for 40 years. So I'm catching up. Anyway, this two-day conference needs to be seen in light of these three strategies. And Chad, before he speaks, I will tell you, is the founder and Chief Technical Officer of Omnex. And I've been with him almost the whole route, and it has been his ability to foresee where things were going to go. So that, for instance, when the need arose for an integrated software solution, we were already developing one that would be web-based and would be comprehensive. When this evolution to 𝐂𝐨𝐬𝐧, I know that he and other leaders in the organization started working on solutions and products to support that five or 7 years ago. And that's been what has enabled that forward thinking, and that being ahead of the curve has been a major contributor to the growth of this company from, what, Chad, 5 people when I joined the company, 5 people when I joined the company to what, 650 or 700, somewhere in that neighborhood, with a global span in every market in the world. I know because with Chad, I've helped open almost every office around the world, 2.5 million miles flying. Chad is on the writing committees for a number of standards. He has published several books and many, many papers, and he has spent over 20 years in system hardware and software development, including leading the development of very sophisticated software solutions to support those activities. He also assesses and works in automotive system hardware and software for Agile, for ASPICE, for functional safety, for ISO 262, and is currently an INTAX TM certified principal assessor. And that's all I'm going to say. That's enough, right? Chad, would you like to join me up here?
Thank you, Miles. Thank you, Dave. Folks, thank you all for being here. Let me start things off by talking to you about what I see as the challenges and strategies in new product development. I have to say, I just want you to know, in the last 40 years, I have had a chance to visit, you name the number of different engineering groups and advanced engineering groups, both at OEMs, tier ones, and all the way to semiconductors. I think you may or may not know, we have worked with every semiconductor manufacturer in the world. And here are my thoughts today in terms of the challenges we face with these standards. I'm going to introduce you to some new terms And we'll see how we can talk about that. Okay. So a little bit on the background of our industry in terms of the challenges, the background of why we are here today, then the key challenges and solutions, and what's next. So here are some things we should all know. So let's take this and make sure we understand. There's even stuff before this, but let me just say the executive order signed by the Biden administration, to set a target for half of the new vehicles sold in 2030 to be zero emission vehicles. That's a target of the US administration. Of course, what's driving that is the idea of, net zero or carbon neutral that all the different countries in the world, together with the United Nations, are trying to accomplish. But even before that, by the way, GM had already set a 2035 goal that is called by some as the most ambitious in the automotive industry of a broader plan to become carbon neutral by 2040. And in that, they are just doing away with combustion engines altogether. I just thought I'd just talk about a couple of the larger automotive organizations. GM, we all know. Volkswagen recently upgraded the electric vehicle target to be 80% of European sales by 2030. That's very ambitious. So, as we know, what's happening then is the mechanical and combustion engine is making its way to mechatronic, electronic, software-based electric vehicles. And my next speaker, Brian, who will join you, will talk to you about SAE levels 1 through 5. Okay, it is something, if you don't know, you need to know. And cars today are predominantly level 2, trying to be level 3, and then going to level 4. As soon as you do level 4, there is a huge big deal. Trucking companies are trying to be level 4. And of course, if you're level 5, we'll all stop buying cars. I'm sure some of us will still buy cars. But the idea would be that you're able to dial up a car and it comes to your front door. So this is what we know. What is happening is first electric and soon autonomous. So if you look and see what's happening is that I want to bring this idea of coupled and uncoupled. Product design was pretty uncoupled till, the advent of electric vehicles and autonomous vehicles. Suddenly, with these electric vehicles and autonomous vehicles, the system, the subsystem, the hardware, the software, the circuit board and the hardware, the components that go into the circuit board, right down to the semiconductor level, are all suddenly connected. So let's see what it is. So before that, I'll just say a couple of things. In this uncoupled system that we had, which will still continue, new product development was a phased approach from planning to product release. And everybody had their own product, development process and release process of their vehicles. In this NPD, so I'm going to be using new product development, I'm going to say the word NPD. In this new product development environment, suddenly we have ASPICE, we have functional safety, we have product cybersecurity. I'll mention sort of much less because I think we're already struggling with 3 of these standards. These 3 standards suddenly have requirements flowing down all the way, right down to the component level. So think about that. Whether you're doing ASPICE, functional safety, or cybersecurity, or AIG, VDA, FMEA, by the way, okay? Your requirements are flowing down. In AIG, VDA, FMEA, the testing doesn't flow up, but the testing flows up. Suddenly, we're in a different world. But I have more slides on this, and let me not take all the time talking about this. And also for 𝐂𝐳, functional safety and cybersecurity, all of them are coupled standards where the entire, right down to the component level, is coupled. All right, so I'm going to introduce this idea of coupled, and the tight coupling of requirements, testing, audits, assessments, reviews, PPAP, our old PPAP, safety case, cybersecurity case, okay? You may or may not know, VDA introduced a software PPAP a couple of years ago. That's not new. I know Marty has already gotten a course in Germany for that. All right. In this era, you can say with or without this electric vehicle move of cybersecurity and functional safety and 𝐂𝐳, well, 𝐂𝐳 came into being. 𝐂𝐳 came into being because we also have the Internet of Things, bringing in a lot of hardware around the world. This is to aerospace, automotive, medical devices, and along with it is software. In fact, some companies are saying they're becoming software companies. All right. So incredible amount of software. And you can see here in 10 million lines of code to 500 millions of lines of code for ADAS, and it's going to grow with autonomous. And much of it with autonomous will also be AI. So as you all know, that's the premise of 𝐂𝐳 is that the system and the software are linked. I know you might think about 𝐂𝐳 as a software standard, but the product in, I'm not going to exactly say the way Dan would like me to say. Sorry about that, Dan. I can't recall it exactly now. But the product in IATF 16949 that we designed in 8.3 is that same system and coupled with the software. Okay, so 𝐂𝐳 brings in new methods of software development and forces a discipline that is new in product development. And what it has resulted in, and you know, I want to be in the forefront of things. So I am also, as Dave said, I'm a principal assessor. I get to see all these different developments going on in all different parts, you know, from everything from I'm going to be doing a hydrogen engine soon to intriguing, isn't it? What are the cool projects I get to see? And so I'm in lots of different semiconductors that we're seeing, bringing in all kinds of new technology. So when I go in there, I see this great influx of brand new people, all software people who don't have an automotive background. You know, I know AP, QP, and PPAP. You all know my background, but they don't even know what that means. So sometimes I write a non-conformance that their 𝐂𝐳 process is not tied to the overall new product development. It's gotten better. I'm talking about something maybe a year or 2 years ago. All right. So we'll bring in the challenges. This is continuing these challenges. What you're seeing here is sort of the 𝐂𝐳, not even just a new product development, the 𝐂𝐳 on the left-hand side. And all those blocks are a little bit supposed to be subsystem, subsystem, and so on. So I'm a little bit disappointed to see the new APQP come out. You know, it's coming out next year, which doesn't have the V model. You know, that's a little disappointing. It's a big missed opportunity. But anyway, here is the 𝐂𝐳 process. The cybersecurity process is right next to it. And the FUSA is right next to it, all being operated in silos, okay? So I do see when I go into the requirements management software for these companies, I do see it all in the same place, but that doesn't make it integrated. All right, so the second point here in this coupled system is to say things are not integrated. New product development with functional safety, 𝐂𝐳, and cybersecurity are not, you know, integrated. The third is the tools don't connect, meaning So what do we end up doing? We end up recreating many things in many environments, and we end up doing a lot of Excel. So we have the requirements tool. So that is mostly automated everywhere. But then the architecture tool is separate. Project management tool is separate. The planning for functional safety and cybersecurity is separate. Configuration management is separate. The threat analysis for cybersecurity is a separate process. The HARA is separate. FEMA is separate. Testing tools are separate. Everything is separate. So, which means then it's all standalone tools that makes it very difficult to operate in this connected environment, right? Or I call it coupled. In this coupled environment, it's very difficult to operate. So what we're talking about is this coupled design where everything flows up and down. And so it's not just in one, this is just in one environment. This is about the environment across, and you'll hear me say the new word, another new word, a design supply chain. We've always heard about the manufacturing supply chain. Because we're in a coupled environment today, we suddenly have a design supply chain, and where many, many, many things are linked together. All right. So how did we define the design supply chain? Supply chain that encompasses suppliers to the system. Whatever system we're talking about, could be the vehicle, right? But typically, probably in this room, other than one or two OEMs who are either calling in or in here, we're talking about a next level system, all right? It encompasses every item in the BOM. Now, usually in the BOM, we don't put software, and we need to start changing that. We need to start putting software in the BOM, because that definitely is a part of what we need to recognize as something separate, all right? So that's how we're defining a design supply chain. And what happens here, I'm going to sort of become very repetitive, requirements flow down. So I highlighted a couple of different processes, all right? So that's what I try to do in bold. Change management, testing, configuration. These are all processes that just don't react within my four walls. It has to work in this design supply chain. Does that make sense? All right, so a summary then of the challenges, and then I have I have a little bit more time, so I was trying to rush. Here are the challenges. New standards require design to be done in concert. It's with the whole design supply chain. We need to even learn how to plan in sort of setting our deadlines and having it translate all the way up and down this connected design supply chain. So, all right. Second, the software design is not integrated. I already mentioned that. I'm summarizing it now. Functional safety and cybersecurity and 𝐂𝐨𝐬𝐧 are in different silos. Linkages and communications in the design supply chain needs mechanisms and tools. I think we can all say that, we need to have these mechanisms and tools to facilitate this communication and linkages. Tools and methods in an organization need to be linked. And we have to talk about the people. I talk a little bit less about it. You'll hear some of our speakers talk a little bit more about the people in the organization. But these new methods, what we mean by that is 𝐂𝐨𝐬𝐧, functional safety, product cybersecurity, they're going to be done by new people who may not know the automotive industry as well, okay? So that's going to be a huge challenge. So where do we go from here? And this is sort of what Dave told you a little bit in my thesis of this presentation. So what we would say is, number one, integrated new product development, model-based and digitalization of methods and tools, We'll talk about that. A connected design supply chain. And then I broke AI separately from digitalization includes AI, broke it separately. AI for checking, coaching, and mentoring. Okay. And so the first one, you can see here, the idea of an integrated new product development. So here are some thoughts, some overall summary thoughts on this integrated management system. Develop each design element so they share, when we mean that, we mean the design supply chain, but including inside your own organization. So they have the same deadlines and oversight. So everybody's able to see, especially at the very top, but you should also be able to see and be able to communicate these deadlines and changes. Outputs of each phase need to be coordinated. So meaning, if we have these phase gate reviews, it should be coordinated with what's going on in cybersecurity, 𝐂𝐨𝐧, and what am I missing? Functional safety. I'm thinking in my head, there's 423 different work products in those different methodologies that I spoke about. So it needs to be coordinated. Conduct gate reviews, which are cumulative, which accumulates up. Reevaluate program management. So the program management took us a long, long time. I have lived this automotive industry's pain and trials and tribulations. It has taken a long time for us to come here in terms of project management and program management. And I think, Marty, you have lived several different programs from Toyota to Magna to many different organizations. And it is not easy. But that is the old paradigm. I'll say more about the old and new paradigms tomorrow. But it's a new paradigm today. And if we continue to operate in that same paradigm, you're not going to get all the signals coming from inside your product development. All right. The other thought is that some of these tasks done in silos need to slowly go inside engineering. I'll tell you this, I don't know if you all know, I did the first worldwide witness audit for QS 9000. And I'll be introducing Mr. Dan Reed there, one of the persons primarily responsible for today's IATF 16949. So I did the first worldwide witness audit, Dan, and it was the same thing. APQP was done by a specialist role, and by the way, not in every company anymore, but it was done in a specialist role by different people, and they had new product development as though there were two separate things, okay? Well, history is repeating itself all over again. But the responsibility for functional safety and product cybersecurity slowly needs to come back into the design team. All right. What about model-based design and digitalization? One tool for all the functionalities of new product development, 𝐂𝐨𝐳, functional safety, and product cybersecurity. It should integrate, sorry about this slide being a little small. It should integrate with the legacy tools. And the idea should be, we cannot replace every tool. You have to integrate with tools which are entrenched in the organization, or it's too much work for the organization, even to take a big innovation. Seamlessly move between the different, which we showed. So this is a new word, if you want to use the new word, coming from more from the software side of things. All these different things that, that we use, configuration, change manager, we think of them as software tools, by the way, okay? So you have to seamlessly move between these tools that do project planning, safety planning, cybersecurity planning, NPD planning, item definition, HARA. We need to slowly, easily go through all of these. And the thought is, it's through model-based design and digitalization. I'll talk to you about the big deal about digitalization in the next few slides, okay? And we think all these deliverables and work products need to be accessible right from the plan. Plan is there, all these deliverables are there. You click what you want to, you're going to go into it. The deliverables are work products. So this is the big deal. I hope I have my slide here, but then I tried to minimize the number of slides I could show. But the deliverables are work products. What do we say? 423 different work products from functional safety, cybersecurity, 𝐂𝐨𝐬𝐧, APQP. You can reduce it by 50%. That is what we're working on right now as we make all these work products, integrate. So what does that mean? If the number of work products go from 423 to 200, what does that mean? More efficiency, right? Maybe even we think half the amount of work. So that's a huge, big deal. All right. And then, of course, we'll use in these work products, many people are new. Nobody's really done a HARA of 10 years. The HARA is, though it's 2011 is when functional safety first came, but even so, nobody has the background in HARAs, TARAs, even AI, GVDA, FMEA. So we're going to have to use AI and machine learning to provide feedback for these deliverables. Provide guidance to the engineer. That's what AI will do, is provide, first it's checking, next is guidance, and then using model-based design, it'll provide, actually a solution. All right, so this is the vision Omnex has for model-based design and digitalization, but it's one of the 4 solutions we think that need to happen. The other thing we need to do, if you don't have it, we need it, is connecting up the supply chain, not just to the next tier. We have to connect all the way down. Why? That's the way the standards are. Or we have to change the way we think we'll do that design. To effectively implement these new standards, we have to communicate right down to the semiconductor level, to the circuit board above that, back into the hardware supplier, back into the subsystem, and so on. Okay. All right. So here are some thoughts in terms of the AI and machine learning. First, we'll do checking. Pete is going to do a much better job on this later today. I'm just doing a little bit, okay? First, with checking, it'll tell you what is wrong, okay? That's what, we have done and will do. And we'd like to do it for all the different deliverables in this integrated work products. And next, what it can do is it can advise the engineer what is the best way to work. That is called a recommendation system. And then what happens is, after we have collected enough information of how design is done, we're going to reuse. I realized my slides for model-based design are in tomorrow's presentation, okay? I had to work on both of those last night. And also you'll see some of my 423 work products coming into 200 work products tomorrow. So this is part of the puzzle. And then, so let's now then look at the summary here. So the advent of electric and autonomous, I think you might be seeing the pain. We've already been going to a couple of different organizations that are seeing the pain of implementing these.
Quick on this subject on that.
All right.
Quick polling question by a show of hands. How many of your organizations have a separate engineering group for functional safety?
I think everybody does.
Because I've been in a couple of the biggest IT companies in the world, and they have a whole division that is engineers doing functional safety. How many of you have a separate engineering group doing cybersecurity? Right, so you got one engineering group doing functional safety, another engineering group doing cybersecurity, and then of course you have an engineering group that are actually designing the product of the system. And that group is separate from the two we just talked about. Show of hands. I would expect almost everybody's. I want to verify with you.
But let me just say this.
Yeah.
That doesn't make everything wrong. Okay. I know, I just have to say that. I just have to say that. Yeah. You know, so it's what we do next and next and next after that. Because what happens is the regular folks don't know these trades, you know. So, but slowly we have to think through what is the best, because something still will have to be done by specialists. And then some things will have to go to the engineering group. Okay. All right. But thank you, Dave. The shift. So the first point is the idea that I introduced earlier about the coupled versus uncoupled new product design process. And that the design supply chain comes into being with the coupled, you know, design. And that the shift has been brought about by 𝐂𝐨𝐬𝐧, functional safety, product cybersecurity. But maybe I can just go back a little bit and say it's something called system engineering. So why do we have system engineering? System engineering is here, and we have a couple of PhDs in the room. Will tell you when the design gets very, very, very complex, as it has become today, we have to go through a systems engineering, which is what, you know, 𝐂𝐨𝐬𝐧, functional safety, cybersecurity is adopted. All right. And the left side of the requirements has been adapted by AIGVDA FMEA. I wish they would know that's what they're doing and how they align with everything else. All right. It is our belief it is impossible to produce a quality and timely new product. We'll come up with something and we might even actually check some boxes, but it's going to be something quite difficult to do with a lot of rework, because without the single tool of MBD, model-based design and digitalization, connecting the design supply chain and integrating new product development, 𝐂𝐨𝐬𝐧, functional safety, and product cybersecurity, it's going to be, we think, quite difficult to do design. And we are seeing the effects of that already, okay? So this is the challenge of the automotive industry, is how can we execute all of these new methods? I call it a trade. All right, you understand. How can we do it effectively? How do we communicate? How do we make sure the new engineer coming into the automotive space understands the legacy that we all have, along with the new things that we have to do? So with that, thank you all very much. And be pleased to tell Marty or Dave, I have 10 seconds left.
Questions?
So I do want to take questions, but I do want to do one more thing, if I could, Dave. I want to have the general managers, we have general managers from our different offices stand up, if you can, please. So I'll start with Martin Hetward from our European office from Berlin. Madhu Balakrishnan. Sorry, Madhu. I made Shankar. Sorry, Madhu. And Arun Kumar and Vijil Matthew, all from our India office, but two different organizations. Arun and Vijil are with Omnex, and Madhu and Sabu are with Omnex Systems. Okay. Well, I'm on that, you know, so Anthony John was our vice president, actually has a dual role in Omnex and Omnex systems, but he actually oversees Omnex systems. Okay. And let's see here. We have Lily Shi. Lily is from a Shanghai office. By the way, we have been in both Shanghai in China. We have 4 offices in China and India for, I'm going to say, I keep saying 25 years, but that was 5 years ago. But so time flies. We went when China, we didn't have one person we could hire in China who knew automotive, with the automotive background, US automotive background. So we actually took somebody from our Thailand office and moved him into China to start our China office. So, and then for India, we went to help Cummins and Dongfeng Motors many years ago in China. And then Mr. Arun Kumar knows very well. We went to help Mahindra Ford joint venture in India, and I don't know how long that was. So with that, I also want to, hey, Vice President. Oh. Mr. Watkins. So Dave and I first started, we were doing QoS for Ford Motor Company. We wrote QoS in 1993 and then spent 3 or 4 or 5 years after that preaching QoS almost every day of our lives. Dave a little longer than me. So Craig, I didn't mention Craig, head of plant tech at Omnex, Craig Thompson. Folks, I also have a few other people I'm very proud of, proud of everybody, but I just want to also introduce Mr. Greg Gruska. He is, he goes so far back, he was in Chevrolet. I'm also ex-General Motors, by the way. And so Greg is one of the writers of the core tools, okay? But so much more, because of his strong reliability background, very much in functional safety, cybersecurity, and SOTF, okay? He's one of the people that help many small little things that people have gone to Greg for, including how to do a one-sided CPK. Somebody once told me, he wrote a whole program on how to do a one-sided CPK. But anyway, all right. Thank you, Greg. We have Dr. Juan Pimentel, and he's on the, so Greg is on the functional safety 26262. Juan is on SOTF and cybersecurity, okay? And who else? I think we have Mary Rousey, one of the writers of the FMEA. She's not here, but she's on the web meeting. And we have Mr. Dan Reed, how shall I say that, Dan? Dan, go ahead and stand up. We should not forget Dan. We were all in awe of Dan when QS 9000 first came. So that will not leave me, Dan. Or when I was in General Motors, they brought Greg in as a consultant back in the good old days, okay? And so those are some of the remembrances I have, And I mentioned to you, before there was the IATF, there was the Automotive Task Force, and Dan was ahead of that, okay?
Yeah, his name tag has "It's my fault."
So thank you, Dan. Let's see if I've missed anybody else. I always like to also, Bill Scher. Let's scroll up the name. I said yesterday he ran the Ford Lean office, but he corrected me. But one of the key people for the Ford Lean office, okay? And because of him, we got pretty much his whole team from Ford are working with us. So I don't think Mike Down is here, right? Mike Down, Mary Rousey, and Greg were a part of the 5 or 6 people who wrote core tools. 3 of them reside in Omnex, we're very proud to say. All right. I don't know if I missed anybody else. I apologize if I did.